Okay, we are on page 25 today, and we're going to continue to work on solving systems of equations. So we're going to focus on substitution and elimination today, those algebraic strategies that we looked at last time. We also saw graphing, but I want to focus on the algebraic stuff for today. So on page 25, we're going to go through a couple examples together. I'm going to ask you guys to try some. And again, we're just going to practice these solving skills. So for number one, remember we've got two strategies here, substitution and elimination. Substitution is when I have y equals some stuff or x equals some stuff, and I plug that stuff in for the appropriate variable in the other equation. And then elimination is when I have something like 3x and negative 3x in my equation, so that when I add the equations together, and other stuff here, when I add the equations together, that variable is gone. So some of these problems are going to be already sort of set up really nicely for substitution. Some of them may be already set up pretty nicely for elimination. So we're going to kind of strategize here. Now, that's not to say that you can't try substitution or you can't try elimination with any particular problem, but for some of them, it would be a lot of work to set up the problem to get that option. So we want to try and sort of make the best choice for the problem we've got in front of us. So for number one, I've got y equals negative 2x plus 2, and then I've got y squared equals 2x. So I could, if I wanted to, use elimination here because I've got negative 2x and positive 2x. We could also, if we wanted to here, use substitution because I've got y equals some stuff. Now, when I plug this stuff in, I'm going to have to square it. Okay, so does anybody have a preference here? Because really, we could use either. Are you feeling really good about one option or the other? We want to do elimination? We could do elimination here. So that means we're going to add these equations together. Now, on the left-hand side, we have y and y squared. We cannot combine those. They are not the same thing. They're not like terms. So we've just got y plus y squared here. Our x's are gone, and all I have left on this side is 2. Now, we're used to factoring things that are x squared plus 5x plus 4 or something like that, but it works the same way if I've got y. So since I've got a quadratic here, a y squared and a y, I'm going to go ahead and move everything to the same side to get standard form. So I get y squared plus y minus 2 equals 0. And then I'm going to try to factor this. If you wanted to use quadratic formula here, you could, but I think factoring would be a little bit faster option. So factors of negative 2, that would add to 1. That would be 2 and negative 1. So this would be y plus 2 times y minus 1. So my solutions here would be y equals negative 2 and y equals 1. Now that I have values for y, I'm going to plug those back into one of my original equations to solve for x. You can plug into whichever equation you prefer. I'm going to plug into the top here so I don't have to mess with the squaring. So when y equals negative 2, and I plug that y value in, I would have negative 2 equals negative 2x plus 2. Now I want to solve for x. So I'm going to move this 2 to the other side. I get negative 4 equals negative 2x. Divide both sides by negative 2. And I get 2 for x. So one of my solutions would be negative 2 and positive 2. Make sure you put it in x comma y. So 2 comma negative 2. X comma y. I'm now going to plug in my other y value. So this would be 1 equals negative 2x plus 2. Move the 2 to the other side, and I get negative 1 equals negative 2x. Divide both sides by negative 2, and I get 1/2 equals x. So there's my y value, there's my x value. Write your solution as an ordered pair, 1/2 comma 1. Questions for me on number 1? Okay, let's take a look at number 3. Now, number 1 was set up so that we could have used substitution or elimination, and we chose elimination. For number 3, if I hop down here, this one's not set up in a way where elimination would really make any sense. I have y and x in the top equation, and then I have x squared and y squared in the bottom equation. I can't eliminate an x with an x squared or a y with a y squared. So we're going to do substitution on this one. That's the only option that really makes a lot of sense. Since I already have y by itself, I can go ahead and plug this in for y in my second equation. So I have 4x squared plus, in parentheses, 4x squared. I don't just tack the square onto the x. I need to square this whole thing. And then equals 20. So this would give me 4x squared plus 4 squared is 16, and then x squared is x squared. And now I've got like terms here. These are both x squared terms, so I can combine them. That would give me 20x squared equals 20. And now I'm going to divide both sides by 20 to get the squared piece by itself. So I get x squared equals 1. Since I only have x squared here, I don't also have an x term. I'm just going to solve this with square roots. So I have the squared piece by itself. I can take a square root now. So I get x equals plus or minus 1, since the square root of 1 is 1. Don't forget that plus or minus. You get 2 solutions here. Now that I found some values for x, I can plug them into either of my original equations to find y. I can always plug into the equation that's going to be a little bit less work, leaves you fewer places to make an error. So I'm going to plug into the top equation here. So I'm going to plug in x equals 1, and I'll plug in x equals negative 1. When I plug in x equals 1, I get y equals 4 times 1, which is just 4. So I have a solution at 1, 4. When I plug in negative 1, I get y equals 4 times negative 1. So y equals negative 4. And I get a solution at negative 1, negative 4. Questions for me on number 3? I want to point out here that we're not really doing anything terribly different with our systems of equations problems. You've seen systems of equations before. These strategies are things that we talked about in Algebra 1. When we get down to just one variable, either through substitution or elimination, what you're left with is the quadratic that you're solving, which is something we've done earlier in this chapter. Once I solve that quadratic, I plug those values in, which is back to something you did in Algebra 1 with systems of equations. Okay, so we took 2 things we know how to do and combined them to be able to do a new thing. Let's take a look at number 4. For number 4, we've got y equals x squared plus 5x minus 10, and y equals 2x plus 18. What I've seen before in Algebra 1 and what I see sometimes in Algebra 2 is that if we have 2 equations that are already set up as y equals, sometimes we get a little nervous about what to do with that. This is an ideal situation for substitution. They're both y equals something, so it doesn't matter which way you think about this. What you're going to end up doing is just setting this stuff equal to each other. So if you think about plugging this in for the y here, that's fine. If you think about plugging this in for the y here, that's fine too. You're going to get the same thing either way. So we'll get x squared plus 5x minus 10 equals 2x plus 18. If you have the side swaps, that's fine. And then since I have x squared and x terms, I'm going to move everything to the same side. I'd like to keep my x squared term with a positive lead coefficient, so I'm going to move everything over here. Okay, I'm going to move everything to the x squared side. That means this 2x needs to move over, and this 18 needs to move over. So I get x squared plus 3x minus 28 equals 0. Again, you could use quadratic formula here if you wanted to. Probably not ideal for completing the square because our b term is odd. So you would have some decimals to deal with there. You could, but most of us probably would prefer to avoid the decimals if we can. This is also something that factors really nicely. Factors of negative 28 that add to 3 would be 7 and negative 4. So I'm going to factor this thing. We get, x plus 7 times x minus 4. So my x values would be negative 7 and 4. Now, just like the other two problems that we've done today, we're going to take our x values and plug them in to one of our original equations. Again, pick the equation that's going to be a little bit less work. If there's one that looks a little bit easier to plug values into, choose that one. So to me, that looks like the second equation, so I'll plug my x values in there. That would give me y equals 2 times negative 7 plus 18. 2 times negative 7 is negative 14 plus 18. That would be 4. So we get when x is negative 7, y equals 4. That would be the point negative 7, comma 4. And then when x equals 4, we would have 2 times 4 plus 18. So 8 plus 18, which would be 26. So when x equals 4, y equals 26. That's our other solution, 4 comma 26. Questions for me on number 4? Couldn't we what? I mean, you could graph any of these, but the point for today is that we're practicing those algebraic methods. Okay, there's one more I want to take a look at together. Hop to the next page. I want to talk about number 7. So number 7 on page 26. I could, if I wanted to, solve this top equation for x. I would get x equals 6 minus y squared, and then I could plug that in for x here. That's fine, but then you're going to have to square 6 minus y squared, okay? Which means distributing that, because it's not just one thing I'm squaring, it's a quantity that I'm squaring. The other option is to use elimination here. If I wanted to use elimination, I don't have a setup for that right now. And my only good option for something to eliminate would be the y squared. So I would need to multiply one of my equations through by negative 1. I want to show you that with number 7, okay? So I'm going to choose elimination here, and I'm going to multiply this top equation by negative 1. So that way I change the sign. I'm going to rewrite that down here. So I get negative x minus y squared equals negative 6. We haven't had to do this with any of our elimination problems yet, so I just wanted to walk through this as a reminder. Now, when I go to add these equations together, my y squareds are gone. I have x squared minus x, remember these are not like terms, I cannot combine them, equals 26 minus 6 is 20. From here, this is really similar to the other problems that we've seen so far, where I've got an x squared term and an x term and a constant term. We're going to move everything to the same side, okay, and get standard form. So I get x squared minus x minus 20 equals 0. And now I'm going to factor on this one. So factors of negative 20 that add to negative 1, that would be negative 5 and 4. So this would give me x minus 5 times x plus 4 equals 0. So my solutions for x here would be 5 and negative 4. Now, just like I have for every other problem, I'm going to plug these values of x in for one of my equations. So I would get, when I plug in x equals 5, you can plug into either one. I'm going to choose to plug into the top one. It's going to save me one step of work if I don't have to square that x value. So I'm going to pick the option that's a little bit shorter, a little bit less work. So this would give me 5 plus y squared equals 6. Move my 5 to the other side. I get y squared equals 1. And now to get y by itself, I need to take a square root. So I get y equals, since I'm taking a square root, plus or minus, and the square root of 1 is just 1. We saw a problem like this yesterday, I believe, when we went through our sort of initial examples, where when I plugged in a value for a variable, I ended up getting 2 different answers for the other one. So that means that we're going to get 2 points here, 5, comma, positive 1, and 5, comma, negative 1. And now I'm going to do the same thing with my other x values. My other x value is -4. Again, I'm going to plug into the top equation, 1 step shorter if I don't have to square my x. And this would be -4 plus y squared equals 6. I want the y squared term by itself, so I've got to move the 4 to the other side, and I get y squared equals 10. To get rid of the square, I'm going to take a square root, and I get y equals plus or minus. Do we know the square root of 10? No. And then the other thing I always want you to check when you have a square root that I should say isn't going to come out to an integer is see if you could reduce it at all. So 10 is 2 times 5. That's as much as this factors. I don't have any pairs there, so I'm not going to be able to reduce this any more than the square root of 10. So y equals plus or minus the square root of 10. Since I've got plus or minus, again, that means 2 points from here. So I get -4, comma, positive root 10, and -4, comma, negative root 10. So 4 solutions on this one. If I looked at the graph, I would have 4 different points of intersection here. Questions for me on number 7? Okay. There are 2 problems left on page 26. Together, I'd like to quickly talk about strategy, but I'm going to leave them for you to try. So if I take a look at number 5, this one's already set up pretty nicely for one of our methods. What might you want to take as your option on 5? I would probably use elimination on number 5. If you add these together, your x squareds will eliminate. How about number 6? You could do elimination. Your x squareds would eliminate. Could you do substitution on this one? This is just like, what was it, number 4 that we looked at, where we had y equals and y equals. If you wanted to, you could plug this in here. So you could use elimination or substitution on this one. If you use elimination, I want you to recognize that on the left, you have y plus y. That's 2y, not just y. And then if we hop back to the problem that we skipped on page 25, this one is set up really nicely for elimination again. It would be a bit of work to be able to get that one to work for substitution. Your better bet would be elimination. So I would like you to try the remaining 3 problems on pages 25 and 26.